All right, welcome back. We're going to be doing a lot of coding today, and our main goal is to basically see arrays as instance variables. We haven't really seen that. We've worked with arrays, but kind of just as local parameters. It's going to be the first time we're seeing them as part of the object. And what we're going to be coding are lottery tickets in a program that kind of simulates the lottery. Now, hold right there. What you're actually going to see at the end of this is what I'm encouraging you to do is not play the lottery. I'm trying to discourage you, in fact, from playing the lottery. Um, it's about this time of year. This was a very timely project a couple of years ago. It was a huge Powerball going on, and everyone was talking about playing the lottery and lottery odds. And so I came up with this project about that time to be like, you're wasting your money if you're buying lottery tickets. Okay. One of my favorite statistics about the lottery is depending, on which lottery and which odds and everything, but one that was going on about the Powerball at the time that was so high was that you had a better chance of getting killed by falling debris from an airplane than winning the lottery. And so I kind of thought I had this notion that everyone that plays the lottery must walk around in constant fear, right? If they believe they have a chance of winning the Powerball, winning the lottery, they must also fear, being struck by lightning or killed by falling debris from a plane, and it must be pretty excruciating to always have that level of anxiety. Let's get started. All right, I'm in IntelliJ. I'm going to make a new project by going to File, New Project. We'll go next, and my folder is already selected, so I can just create my project name, which I'm just going to call Lottery. So the project is called Lottery, but the object that we're going to be making is a lottery ticket. So I'm going to make a new a new Java class called Lottery Ticket. And the big takeaway from today is we're going to have an instance variable here that represents our lottery numbers, right? All a lottery ticket really is a series of numbers, right? So while this is like a physical object, those numbers are just there, and we'll use an integer array in order to save those things, right? So I'm going to create an integer array as an instance variable. Here I'm calling it nums. Okay, if you're rusty on arrays, that's okay. Part of this project is to kind of get you back in the groove of that, and we're going to be seeing a lot more of this. We're going to be seeing a lot more of pretty much the rest of the unit is that we're going to be working with arrays as instance variables in our objects. Okay, so we have our instance variable. There's probably not much else. An actual lottery ticket may have something like a serial number or something to kind of verify that it's legitimate. But we are going to now move to our constructors. So I'm going to have a lottery ticket here, lottery ticket constructor. Sorry, I'm looking at previous code because I did such a good job before that I want to kind of replicate that. So this is going to take in a parameter, a length, right? And as you imagine, it's effectively the number of numbers involved in this lottery ticket. Okay, like all instance variables, I need to initialize it in the constructor. So we're going to take nums and we need to initialize it. Now, this is where it's kind of like, oh, arrays are back, right? How do I initialize this array? I've declared an integer array called nums. I need to give it a value. I need to create a brand new int array with a particular length. That's where this parameter comes in, right? You could standardize this, right? We can make something like a no args lottery ticket that maybe only has like 5 or 6 numbers. Here, I'm basically going to give the user kind of maximum flexibility by saying on the spot how long they want their lottery ticket to be. And this will also be good for us to test. Right, we can make lottery tickets with like 3 numbers. We can make lottery tickets with 4 numbers. Typically, lottery tickets are something like 5 or 6 numbers. So that's what we'll probably end up using in practice. But this length variable is going to come in. It's going to tell us how many numbers are involved in the lottery ticket, and that is how long our integer array should be. Okay. So from there, we need to actually kind of populate or put numbers into this thing, right? So there's going to be some type of logic here, right? We want to fill the lottery ticket with numbers. And so that's where like a discussion comes in. And it seems like what we've done in the past is that we've had numbers in the range 1 to 59. Right? Fill the lottery ticket with numbers in the range 1 to 59. I believe this was like trying to mimic the Powerball. And there's a note here that numbers in nums are unique. Okay. So this is actually the hardest part about this entire project is how do you do this, right? Effectively, we want to random a number and we want to insert it in the next available index in nums. But I don't want to insert it if it's a duplicate, right? Now might be a good spot to pause if you want to attempt this one on your own. It is a bit challenging, I'm not going to lie. I'm going to dive right into it, right? We need to basically, I just want to make one pass over nums, right? I don't want to have to backtrack. So with that in mind, we could use a for loop. Here I have a while loop, and it'll make a little bit of sense here in just a moment why we're doing that. So we're going to create I. We're going to use it to track our position in nums. I just want to make one pass over nums, right? What that's going to mean is that I don't like have to kind of backtrack and change numbers. Anyway, let's start looping. Okay, this variable I is going to be part of my loop here, right? This is starting to look like a for loop because our condition is going to be as long as I is less than nums.length. All right, this is what I mean by we're just going to make one pass. And here's what I want to do. I'm at a spot where I want to basically random a number and insert it. Okay, let's random the number first. I need to come up with a number first before I decide if it's good or not. So we are going to create num, singular. Maybe that's not a good variable name because it's going to get confused with nums. Let's go with x. How about that? And x is going to be our random number. Okay, let's use math.random. Right. Math.random is going to give me a random number in the range 0 to 1, and that's a double, which is why there's a syntax error here. All right, so we want to cast that. Now, if I do this, IntelliJ right away is just like, you're going to get 0 every single time, right? We're applying a cast to this. The number range is 0.0 to 1.0, inclusive, exclusive. You'll notice it will never quite hit 1, so we're getting numbers that are like 0 point something every single time. That cast is causing this to be 0 every single time. Okay, so we're going to apply some math to this in order to get the correct number range that we want. Now that we're working with integers, right, we can multiply. I've told you many times that we want the multiplication to be number of possibilities. How many number of possibilities are there in this number range? Okay, there are 59 numbers there in that number range, 1 to 59, inclusive on both ends. So there are 59 possibilities. Now what this is going to give me at this point, once I put this in parentheses, right, I want the multiplication to happen first, right? The first thing that's going to happen is we're going to go inside these parentheses. We're going to do math.random to give us this number range. We'll then multiply that result by 59. Then the cast gets applied. As it stands right now, our number range is, since we're casting, 0 to 59. Sorry, 0 to 59, inclusive, exclusive. Meaning I am getting 0, which is not quite what I want, and we're not quite getting 59. Another way to think about this is 0 to 58, inclusive on both ends. Okay, there are 59 possibilities in that number range. I just need to shift it just by 1, so I'll add 1, making this number range 1 to 59, which is what I want. All right, so we're looping through our array. I'm going to random a number. I now want to insert that number, but only if it's unique. Okay, so what I really want here is some type of, you could do it on the spot. You can make another loop. You can nest a loop basically where you come up with j or something, some other variable, and you loop back through nums so far to see is the number there type of thing. I recommend, just for sanity's sake, that we write a helper method. That is some type of method that only exists to help in the operation of this class, of this object. So I'm going to write a contains method. Okay, a couple things real quick. This is probably the first time we've done this. Right? This method is private. This is because I don't want my other classes to use it. I don't expect them to. Right? I'm making it private so that this is the only class that can use it. And that's kind of what makes this a helper method. Right? It exists only in this class to kind of help with operations. Again, everything that I'm about to do in contains could be done right here on the spot, but this contains method, as you're going to see, I think cleans it up. Okay, the idea behind contains is, and you don't normally or have to JavaDoc this since it's private, right? And JavaDoc is the stuff that we see in some type of API, but maybe it's a good idea, right? So param_x is the number to look for. Our return is going to be true if nums contains x, false otherwise. Okay. One of the reasons why this is private and why I don't want other classes accessing it is because it is going to be using nums directly, right? If we wrote kind of a generic contains method, it would likely be static, and you would likely need to pass in the integer array along with what you're looking for in order for that to actually execute. But here, since it's private, since I'm in this class, I can directly access nums. No need to pass it in as a parameter. But I'm saying right here that we're going to be looking through nums, and that's it. Okay? So, in theory, we've written one of these before, right? We wrote a static version of this, array helper, last year. Here, it's not static. It's a helper method. We're referring to nums. Let's go. All right, I'm just going to loop through it, and the moment that I find x, I've found it, and I can stop there. Okay? You could actually use a for or a for each loop here. I'll show you both. Okay, what most people are probably used to is the just the standard for loop. Right, I is going to start at index 0 as long as I is. Let's back this up. So my shortcut syntax here is for I. IntelliJ is highlighting the I because I have the opportunity of renaming that if I want to. I can rename it whatever I want, and notice that all other instances of it also get renamed. Now, to pick a very good name, I is okay here because this I only exists in this scope. This I is going to exist only in this scope. My next opportunity is if I hit tab, we're going to tab over to the condition. It wants to know as long as I is less than what? In this case, nums.length. With each iteration, I'm going to ask, is the current value the one I'm looking for? If nums at I is equal to x. Right? Nums is the array. I is an index. Nums at I is an element, a single integer. I'm asking, is that integer equal to x, the one that I'm looking for? If so, I can stop right there. We can return true, which is going to, of course, exit the method. The moment we hit a return statement, we leave the method. Okay. This for loop effectively only has one statement in it, this if statement. I know this looks like 2 lines, but the only statement that's in the for loop is the if statement, meaning I don't have to have these braces. In practice, your company will give you a styling guide to tell you if they want that or not. If I manage to go through the entire array, that is, the loop's done, I've checked every element, and I still haven't found it, we're going to return false. Okay, so here's our for loop approach. It works, I promise. I'm going to rewrite it with a for each loop. Okay, the array that we're looping through is nums, which means it's an integer array, and each individual element is an integer. So I will say for each int, which we will refer to as num current. X will be my go-to here, but I already have an X. How about current? for each integer, which we will refer to as current, in nums. This is our for each loop, right? Nums is an integer array, so each individual element is an integer. I get to make up a name here. It's a variable. So the way I would read this in English is for each integer, which we will refer to as current, in nums. We're going to do something. Okay? It's essentially the same thing. With each iteration, I want to ask, is the current number, in this case it's literally called current, equal to x? Okay? Notice there's no I, there's no index. This is the element. Right? Current is the element. So I'm asking, is the current element equal to x? If so, I have found it. We can return true. Otherwise, we can return false. Now, you probably hate for each loops because most of my students hate for each loops at this point. For each loops are going to become, you're going to like them a lot more as we get into objects and object arrays. I understand kind of the disdain for them right now. Usually it's because somebody, you'll write it and then realize later you have an index and you got to change it. And so most people are just like, well, I'll just make a standard for loop every time. That way I already have the index, that sort of thing. But I think you will come to like these. The real benefit of a for each loop is it makes stuff clean. It helps clean this up. Now, that's not a big deal when we're dealing with just integers, but when we get into object arrays, right? When you're looping through not just an integer array, but like a string array, this cleanliness tends to be pretty nice. All right, we got a contains method going. I'm going to go back to my lottery ticket constructor. We're looping through nums. We just random a number. I'm going to insert that number at the current index, but only if it's not already in nums. That's where contains comes in. Okay? If nums effectively contains x, more particularly, I want to know if it does not contain it. All right, so x is the value that we just randomed. We're going to pass it to this contains method. Contains is going to loop through nums. If it finds it, it's going to return true. All right? So in the event that I get a false value, that's when I want to add it, right? So the way this reads is if nums does not contain x, then that means we are safe to add it. X is unique. Right? X is unique. Unique. If this is true, right? If nums does not contain x, it's a unique number, I'm free to add it. Let's add it. I'm going to insert it at the current position. Nums at I is going to become x. And then we're good. Right? One of the thoughts is that we need to increment I so we move on to the next element, but here's what I'm going to do. I'm going to take this I++, and I'm only going to do it inside of this if statement. Okay, the logic here is I only want to move on to the next index if we manage to insert a number. What's going to happen in the event that let's kind of maybe think about a couple of iterations, right? I'm at the first index, we're less than the length, we random a number, we would see if it's there, likely not, which by the way, what is this thing actually filled with initially? The answer here is zeros, right? And it's a good thing that our numbers are 1 to 59 because then we don't have to worry about those zeros, right? There was past iterations of this, I included 0 as a possible number, but then you got to start checking for zeros. That's disgusting, right? So this thing, when it gets created, it's filled with nothing but zeros, and that's good because if we were to random a 0 and then try to add it, well, it's not a unique number because the thing's already filled with zeros, so that was causing problems. Simple, big brain move here is just don't include 0. Anyway, we're looping through, we random a number. If it's not already there, if it's a unique number, we're going to insert at the current spot and then increment I. So in the next iteration, when I come back through, we random a number and it's unique. We insert it at a new position. Okay, let's suppose that we get here, we random a number and it's not unique, right? We do contains x, gives me true, right? Nums does contain x. we take a not value giving us a false, we would skip over this if statement, meaning I does not increment. That's good. I'm not ready to move on to the next index yet because I randomed a non-unique number. We would come back through, random a number, hopefully not get the same one. Now, I kind of hope you're recognizing that there is a possibility that this kind of loops indefinitely, but you just got to recognize that the chances of that are low in our current implementation. Okay. Probably about another way you could do this to kind of maybe shave off some iterations but add problems is you create an array 1 through 59, right, with these unique values. And you random an index. And effectively, once you random a slot, you remove that number, add it to your lottery ticket, and then that way every number that you random is unique. So there's other ways of doing this. This is the implementation that we're kind of running with. All right, this is it. This should fill our lottery ticket. I'm actually at a point where I kind of want to test it out. So to do that, I'm going to create a string, a toString, I should say. I want to see what's in my lottery ticket. Okay, so let's. I'm thinking we can kind of like piece together our lottery ticket so that it looks something like, I guess Javadoc would be a good idea. We're going to return a string representation of this lottery ticket object. Represent T-A-T-I-O-N. Okay. In the format, and then I want something that kind of looks like this. And we're using like 5 or 6 numbers here to kind of demonstrate it. X would be unique numbers, not the same one over and over and over again. Let's get started with that. First thing I'm going to do is create some type of string that I plan on returning. Initially, it could just be this bracket, right? This opening bracket. Okay, now I'm at a point where I want to get these bad boys and add them to my return string. You're going to notice that, right, we're going to get the value from nums, add it to our return string, and then tack on a comma space. Number from nums, tack on a comma space. We keep repeating that. The only potential problem is here. There's 2 ways to kind of approach this, and there's generally 2 ways to approach these problems in computer science. One is preventative. That is, don't add the comma and space to begin with. Another is a rollback approach, I guess is what it's called, is where you would add the comma and space and then delete it. I don't really care which approach you go to. They both have their pros and cons. Okay, why don't I show you both? If you're going to do the preventative approach, you probably want a loop. Right? The idea here would be you would loop through nums. We're going to get the current element and add it to our return string. Okay, so RTN is going to be what it is plus the current element, which is nums at I, plus a comma space. Okay, hopefully you're recognizing that this could be just a shorthand assignment operator. So we can say RTN plus equals the current element along with a comma and space. That's the same thing. Okay, but I said that this is supposed to be preventative, and hopefully you're recognizing that this would actually give me a comma and space after the last element. So if we're going to do a preventative approach, I would say let's just stop 1 iteration early. Right? So we would effectively have this in our return string. Right? The opening bracket's done here. In the loop, we get these first 4 elements out of our 5. After the loop, what I'm going to do is do this one manually. What do I mean? Just not inside the loop. RTN is going to be what it is, along with the last element, which is nums at nums.length minus 1. Okay, while we're here, so that's just going to tack on just the last element. But while we're here, let's go ahead and add on the closing bracket. And that should be everything. I'm ready to return it. I want to test this. We'll see that it works. Yeah. The only potential problem here is that if nums has a length of 0, but just don't do that. We would maybe precondition our lottery ticket number to say that length is something greater than 0. How about something in the number range, which, by the way, if these numbers are going to be unique, you also don't want length to be equal to, what, 59 or 60, because you can't have 60 unique numbers when it's in your number range 1 to 59. So one thing I would say about this, probably as a precondition, we would say that length is greater than 0, but less than 60. Right? Length is going to be in this number range. It's going to be greater than 0, but it's going to be less than 60. Okay? Having this precondition here means I don't have to worry about the length of nums being 0 down here and going out of bounds. I'm going to make a driver. We're going to make a lottery ticket, and we're going to get to a stopping point in this. Okay, so here we go. Let's make a lottery ticket. And it is a new lottery ticket, and let's just give it, let's just do like a length of 3. Something small to kind of make sure that our program's working. And I want to print off my lottery ticket, which is going to implicitly call the toString. We want to make sure that's working as well. I'm going to right click in free space, tell it to run. And there we go. We got unique numbers. Granted, my sample size isn't that great. We could do something crazy. Hopefully this executes kind of quickly. You could imagine that the potential holdup being that we random a number, we random a duplicate, and the likelihood of randoming a duplicate gets larger, you know, the more numbers that we have. For instance, if I go full on 59, I'm not, but if I did full on 59, that means every number has to be unique. And as you can imagine, we're going to hit duplicates and have to random again, and that ends up adding a lot of processing. But when we're talking about just like 5 numbers, the likelihood of getting duplicates is actually relatively low. Okay, last thing I want to show you before we pause it, and this is going to end up being a part 1 of 2, is looking at this with a different approach, right? This is the preventative approach. I want to prevent the comma in space. Another approach is to just go ahead and tackle on the comma in space after the last element, but then delete it, roll it back. Okay, for that, you could actually use a for loop. So I'm going to say for integer x in nums. We're looping through nums. Each individual element is a single integer. I'm going to refer to it as x. This syntax is clean. Okay. What I'm going to do is, we've already got our opening bracket. I want to take RTN. I want it to be what it currently is, along with the current element, which is x, plus a comma and space. And I'm not going to stop early, which means what our string looks like at this point is something like that, right? Where I've got an extra comma and space at the end. What I want to do is get rid of that. I want to delete it. Hopefully, as you know, you can't really delete from strings. All you're really doing is creating new strings. So what we're going to do is take a substring. We're going to basically keep that portion, right? We're going to keep everything but the last 2 characters. So I want RTN to become what it currently is. We'll use a shorthand assignment operator in just a second. Actually, what I want it to be is a substring of itself, beginning at this index, which is 0, up to this index, exclusive. All right? Why don't I put some like nonsensical characters here? All right, so this guy is, it's a space, but I want to put something there so you can see it, because this is effectively length. This would be like out of bounds, right? So length, I want to go here, I want to go here, -2. Okay, so I want to do a substring of RTN starting at index 0 up to this character, which is going to be rtn.length minus 2. I'm going to keep everything but the last two characters. Okay, so at that point, RTN is that. I just need to tack on the ending bracket, which we can do right here. Should probably put in quotes, which would give us our final string. We then return it. I'm going to run my driver. Again, you see that our lottery ticket looks good. If I were to comment this out, we would see the state, right, is going to have that comma space and no bracket. So I just kind of want to show you what this looks like. We are just adding the comma and space and then rolling it back, deleting it after the fact. So again, both have their pros and cons, right? This is really clean in terms of a loop. You just have this messy step as opposed to the for loop, which was a little bit messier in terms of the loop, but maybe a little bit cleaner in terms of, you know, just doing a manual element add after that. But we're going to pause our video there. I'll come back with a part 2 where we end up making a driver and we actually, you know, play the lottery. See you in the next one.